The dividend discount model is a tool equity investors can use to determine how much to pay for a stock. In words, the dividend discount model simply says that a stock's price should equal the present value of all expected future cash flows. Now, there's a couple of key terms in this definition that I want to focus on. First, we have this phrase, the present value of all expected future cash flows. We're going to call this term the stock's intrinsic value, and we will label that with V. This is essentially how much the stock should be worth given current information. Second term in this definition that's crucial is price. Now, a stock price is market determined, and we will use P to indicate the stock price. And when I say market determined, what I mean is it's something that you can look up, and it is a result of buying and selling activity in the open market. Now, what does one do with the V and the P in the context of the dividend discount model? Well, one who's thinking about buying or selling a stock simply compares these two. So you've got a couple of cases. One, price is less than V. And so if price is less than intrinsic value, what that means is the stock is cheap, right? It's selling for less than what we think it should be worth. And so if the stock is cheap, that's a buy signal. On the other hand, if P is greater than V, then its price is more than we think it should be worth, and so we would say that stock is expensive, and we'd take that as a sell signal. So in the next few slides, we have a couple of objectives. First, we're going to define the dividend discount model. Now, we've already done this in words, and so the definition that we'll be working with going forward is going to be some equations. And then once we've begun defining the dividend discount model, we'll also take a look at a few specific examples. And so this is going to be actual numbers, so dividends, discount rates, and prices. And then once we're done with all of this, we'll move into some separate discussion of special cases of the dividend discount model. Now, before we proceed, I'd like to offer a few terms that need to be defined. So in the formulas that you see going forward, we'll have, you'll see a V, you'll see some D's, and you'll see some K's. The V term is a present value, or the intrinsic value that we've already talked about. The D's are dividend payments or expected future dividend payments, and so the D's are going to correspond to the expected future cash flows that we think about for calculating intrinsic values. And the K term that you see is a discount rate, or an investor's required rate of return. In some textbooks, the K might show up as an R. So a K and an R are essentially the same thing. In the V's and the D's we see, we'll have subscripts to indicate timing. So for example, V0 means the intrinsic value at time 0 or right now, and a D1 indicates an expected dividend at time 1, and D2 2 indicates an expected dividend at time 2. Let's start with a basic stock investment. Here, an investor plans to purchase a share of stock today, hold it 1 year until it pays him an annual dividend, and then sell it immediately in the open market. Our task is to find V using the dividend discount model. So let's begin by writing a timeline. Now this timeline is really simple because there is only one period in the problem. Right? This is a 1 year holding period. And so what are the cash flows? The cash flows are, first, there's going to be an annual dividend, and we'll call that D1 because it happens 1 year from today. And second, the investor is going to sell the stock also 1 year from today. And so we need some expected price at time 1, so we'll call that P1. And so putting those on the timeline, we see this, D1 plus P1 combined as the time 1 cash flow. Our valuation equation, our equation for intrinsic value, is simply V0 equals this time 1 cash flow in the numerator, discounted 1 period, so I'll have a 1 plus K in the denominator. And so in order to solve the problem, we just need to know what each of these time 1 cash flows are, and then finally we'll need a discount rate, K. And so for this problem, I'm just going to give these numbers to you. So let's suppose that we expect the dividend at time 1 to equal 2, the sales price at time 1 to equal 26, and the discount rate, which accounts for the risk level of the cash flows, is 12%. So let's plug these numbers in. So we have 2 plus 26 here, and our valuation formula becomes 2 plus 26, or 28 in the numerator, and 1.12 in the denominator. Solving that expression, we get an intrinsic value of 25. And so again, this is the number here that says how much the stock price should be. And so we'll just take that number as a stock investor and compare this to whatever current price we observe in the market. Now, when we work this problem, I simply provided this number. So the expected price 1 year from now is $26. But I want to offer a little insight now into how we can think of this number. And so to do that, let's go 1 period into the future and ask what this P1 really should be. And it turns out we can think of P1 as in sort of the same way we thought about P0. And so that is, we can once again think of a 1 period investor who's going to purchase the stock 1 year from now, hold it a year until it pays an annual dividend, and then sell it immediately in the open market. And so the timing has changed a little bit, but conceptually we still have a 1 period timeline, right? The only difference here, again, is the time of purchase is time 1, and so we'll put a 1 here, and then this single dividend that we've identified in this second problem is going to be D2, not D1, and then the sell it immediately, that'll happen at time 2 as well, so we're going to have a P2 there. And so our timeline still is a 1 period timeline, but we're looking at period 1 and period 2, and then the dividend and price that go on the timeline are D1 and, D2 and P2. Now, we're solving for V1 instead of V0. That is the expected intrinsic value at time 1. And so the intrinsic value at time 1 is D2 plus P2 in the numerator, discounted again, only one period, right? So don't be confused by the fact that this happens at time 2. We're just going back one period to time 1, and so that's why we don't have a squared term in the denominator. And so in order to solve this problem, we just need some values for D2 and P2. And so I'll give you D2. Let's say we've done some calculations, and we expect that to be $2.08. And then P2, we expect to be 27.04. And so we can insert those numbers into this formula. We have $2.08 and another $27.04 in the numerator. Keep the same discount rate as before, 12%, so we have 1.12 in the denominator. You'll find the $26 that we used in the previous slide. Now, how can we think about P2? Unfortunately, we can roll forward once again as before and repeat this process again for a future one-period investor. We need some inputs once again, and so this time we'll have D3. Let's make that $2.16, and the sales price, we need a P3. We'll make that $28.12. And so once again, we have a one-period timeline. We're just talking about different dates. And so we've got period 2 to period 3. Here we've got a D3 and P3, which are 216 and 28.12. Solving for V2, we have D3 plus P3 in the numerator, 1 plus K in the denominator. Inserting the values. We have this, which equals $27.04. Okay, at this point we've estimated the price of the stock at 3 different times. Time 0, time 1, and time 2. And in each of these cases, we've just used an estimate of the intrinsic value at the appropriate time. So let's compile all those estimates together, and we can see each of those here. And again, we'll notice that in each case, we've got an estimate at a given point in time. So here's time 0. We're basing that estimate on the cash flows in the next period. So here for time 0, we've based the estimate on the cash flows at time 1. So for our next exercise, I want to take these various estimates and combine them. And so let's substitute it in to this equation, and then in a next step, let's take this estimate of P2 and substitute it into this equation for P2. And if we do that, we can rewrite our estimate of P0 as an estimate of intrinsic value at time 0 to be the following. D1 discounted 1 period plus D2 discounted 2 periods plus the sum of D3 and P3 discounted 3 periods. So the implication here is that this formula and this formula are equivalent. And so why does that matter? Why is that useful to us? Well, it's useful because now we realize that we can do stock valuation without knowing a specific holding period. So let's say you're a 1-period investor. You don't necessarily, in other words, regardless of your intended holding period, you can value a stock from the perspective of a 1-period investor, or from the perspective of a 3-period investor, or from the perspective of really whatever investment horizon you choose. And ultimately, this choice it really comes down to which sets of cash flows we can most easily estimate. And so one final step here, I want to just offer you a very general formula, and then we'll tie this all back together with the statement of the dividend discount model. And so just to illustrate that we can pick any time we want on the timeline, we're going to label a price PH. And all that means is this is going to be the price at some arbitrary time H years from now. And so following the same setup that we've used before, we know that we can always say that our estimate of pH is just going to be our expected intrinsic value at time H, which equals the dividend in the next period, so dividend at H plus 1, plus the expected price at H plus 1, again, discounted 1 period. And so bringing that back into this type of a formula, we can say very generally, if H is big, that our estimate for a stock price is simply, again, our estimate of intrinsic value, which can be defined as the present value of the first dividend plus the present value of the second dividend plus present value of all future dividends all the way up until time H plus the present value of some terminal or time H dividend and time H price. And so again, if H becomes really big, this term here becomes very distant in the future. And as we make H bigger and bigger and bigger and bigger and bigger, then this final term in present value terms becomes completely meaningless to the formula, and we simply have this, right? So H has gone all the way to infinity, and so we've got D all the way to infinity, and we simply have the estimate for intrinsic value is equal to the present value of all future dividends. And so that's our original statement of the dividend discount model. And so you'll see it either like this, or in summation notation. These are equivalent.